Hello coffee lovers, welcome to Tron Caffe. Today we will be looking at modding the Gaggia Classic Pro 2019 UK version. The Gaggia Classic Pro Espresso machine makes great coffee in its original form, straight out of the box. But if you want to have more controls over the temperature, pressure, and flow rate to brew more consistent drinks, then this series of mod videos is for you. A couple of advice before you start modding your machine. Firstly, safety is the number one priority. Take the necessary precautions before you start. Secondly, modding the machine voids the machine warranty, so you may want to consider modding the machine after the warranty of the machine has expired. For this mod, I will be using the kit from Shades of Coffee. Without further ado, let's have a look at what is in the kit. You may choose to purchase your own components instead of getting the entire kit, of course. I'll be adding the brew temperature PID, steam temperature control, the pressure gauge, and the dimmer switch to control the brew pressure, and as well as the top box, which is a small enclosure to hold these mode control components together for ease of use. And an additional thing I ordered was a blind filter, which is necessary to test the pressure after the modification. Here we have the user manual, the flow control cables, the pressure gauge, the flow control electronics, some accessories for the top box with the extension tubing for the water tank, the thermal paste for the thermal sensor, and some cable ties for the thermal sensor, other cables. Here we have the thermal sensor, which will replace the thermostat in the Gaggia machine.
Yes. Let me see what's this. Oh, this is the PID controller.
This is the PID controller.
Okay. And some instructions.
The user manual for the PID controller.
All the mods.
The top box
PID controller.
for the PID controller, the pressure gauge, and the Potmeter on the right side. The back is for ventilation, and the left, some holes. I do not know the reason for that. Could be just for extra ventilation. In this box we have the pressure gauge and some parts for the manifold extension. The pressure gauge range is from 0 to 16 bars, which is perfect for espresso extraction. The dial is not so decorative or colorful, but is usable for our purpose. You may source for an alternative gauge if you like.
Start with the switches.
Next we have the solid state relay, in this case for steaming function. Do not mix it up with the brew solid state relay. They are different.
Respective packs, so you won't get confused.
So this is the solid state relay for brewing. One of the cable comes with a fuse in line.
Okay.
Now we have a look at the PID controller. Yeah, the pin out is stated on the labels, one on each side, so should be quite easy to connect them out. Yeah, some tactile buttons. Next we have the pressure control cables. As part of they call this the dimmer switch. We will look into the details as we start to assemble it later on. And yeah, it comes with its own electronics. Next we look at the tools required. Firstly, the multimeter, if you can find one. It's useful for safety check, connectivity and thermosensor test later on. Some screwdrivers, flat and Phillips screwdrivers. And not forgetting a piece of towel. Some spillage. Alright. And time to start to put everything together. Before I do that, I've prepared the assembly of the cable for the pressure controller. I've done some so it's quite simple. Just follow the instructions from the manual. This is the lamp controller. Just make sure the cables are securely fixed, screwed down, because there's going to be quite a bit of yanking when you try to squeeze it into the machine. So there we have the enclosure for the electronics, for the flow controller. Yeah, it takes a while to figure out how to put it in, but yeah, there you go. And here we have some knobs and extension cables for the flow controller. I've done some. We will figure out that later. Pre-assembly. And same for this. Here we have the steamer, solid state relay. Make sure just make sure it's SSR40AA. So don't mix it up with the brew solid state relay. We have the brew. So this is for the brew solid state relay, SSR40DA. Make sure the cables are securely screwed down. For your safety, in the following steps, please remove the power cable from the machine and remove the cable. So make sure no cable. Remove the drip tray. Remove the water tank. Remove the water tank cover on the top. Now unscrew the top two screws with the Phillips driver. To remove the top cover, slide it towards the back. Under the metal top cover, you will find two ground cables. These need to be removed. Use a flat driver to pry the connector slightly away from the top cover. I don't think it's possible to remove it completely with a flat driver. So this will be the first step. Next we follow with a pair of pliers to pull this connector out. Just be careful not to break the cable from the connector. As you can see, it's quite difficult to pull out the cable, so, and at the same time there are screws above, so put aside the screw, remove them first before you continue pulling the cable.
It's pretty sharp, so you need to be careful. Yeah, you need a plier. So that is off. I put that aside.
Now that we have the top cover removed, let's have a good look around inside and document it. Video every corner of the inside as a reference so that when we reassemble the machine, we will not miss out any small details. Here we see the overpressure valve. We will not be modifying it. At the top we see these power delivery cables from the mains. And underneath it is the pump assembly, and there are two screws around the pump which we will be removing later. Yeah, this is one of the screw right underneath, a Phillips head screw. It's quite hard to access, so you need a long screwdriver if you can find one. The black component on the left is a manifold to the boiler, and above it the pump. Next, the brew thermostat is on the bottom left of the boiler, the black color piece. I noticed some of the cables are touching the boiler. I am assuming these cables are properly rated for high temperature. So this is the pump. As you can see on the pump, it is rated at 230 volt, 50 Hz. Do take note of the position of the nut for the steam valve. It is a useful reference for reassembly later on.
First step is to remove this knob. So you're supposed to pull it straight out.
Next we pull out the knob for the steam valve. Very simple. Remove the outlet pipe if you have not already done so, and we are going to prepare to remove the nut holding the outlet pipe. The outlet pipe is connected to the tubing from the manifold, so use a spanner and to put the machine flat on its back and just give it a slight twist. It's quite easy to remove this.
Okay, it's not too difficult at all. It's quite loose, so let's try. Okay.
I'm doing this very slowly, so just so you get to see how it is done.
Just remove this. So easy. It's not too tight. Not too tight. Okay.
So that's the tubing the pipe is connected to. Just gently pull it out a little. So the whole purpose of removing this is that we get to turn the boiler to its side later on. So that is the tubing connection to the outlet pipe at the base of it. So pulling it out, yeah, that's as simple as that.
Connected here. Okay, and this thing goes there. Yeah. So next, I'm gonna remove these three.
Next step,
Connectors.
disconnect the real power feed connectors. It is rather simple. You just need to know where each of these color cable go to, so that you know how to put back later on. The idea is simple, but as you will find out when you try it yourself, it's tough. It's stubbornly connected, so you need quite a bit of force, but at the same time you do not want to damage the cables. Part of the reason for making this video is to help myself, so I know how to put back the machine later on. You need a heavy amount of patience to do this, and just make sure you do not damage the cables or the connectors. Yeah, that's it for the power feed cables. Next, we look at the pump assembly. We need to remove 2 screws from the base of the pump assembly so that we are able to move the whole pump assembly freely, just to unconstrain it from the enclosure. So just under the screwdriver, you will see 1 screw, 1 Phillips head self-tapping screw. So that is 1. Now on the other side of the assembly, we find another screw. So this is a second screw to remove. So I'm zooming in now, that's the one. Alright, so these 2 screws are quite deep in. If you can get a Phillips driver that is at least 1 feet long, mine is 6 inches, so it's rather short, but still doable. Alright, I finally removed the 2 screws and unconstrained the pump assembly. So that's one of the self-tapping screws
on the bottom end.
Yeah, I don't like these self-tapping screws, but this is how they save cost, I guess.
I remove the...
Next, we will unconstrain the group body from the machine. Here we need an M4 Allen key to remove the 4 screws. Put the machine on its back and use Allen key to remove the 4 screws. The screws aren't very tight, so remember the force used to remove these screws, because you need to use the same amount of force when you reassemble it. The boiler is made of aluminum, so you do not want to use excessive force when you tighten the screw back on later. This is to avoid stripping the threads on the boiler. We continue to remove the rest of the screws from the group body. Now that we have removed the 4 screws from the group head, you will find that the boiler is unconstrained from the machine, but not entirely so because the steam vent is in the way, so that will be the next step. The purpose of removing the steam vent is to fully unconstrain the boiler so that we are able to get access to the thermostat eventually. We will use a spanner to remove the nut, but you need to be careful about the cable connector on the left. So position your spanner in such a way that it doesn't clash with the cable. Right? Either you may rotate the cable a little, but you need to position your spanner accordingly as well. Alright, that wasn't too difficult. It wasn't very tight, but we just need to take note to make sure we reassemble it back carefully, because we do not want any leaks at this joint. Do note that there is an O-ring between the joints, so this needs to be pushed in to the joint later on. The O-ring between the joints is in good shape, so that's a good thing. Next, we'll disconnect the thermostat connectors. There are 2 of them, the 2 white connectors at the bottom. We start with the flathead driver again. This promises to be difficult, but that's the reason why we remove the steam vent and the group head screws, and use a piece of rag on the right to prevent scratching the inside of the machine. And there you see the 2 connectors which I'm trying to remove. Yes, after a long struggle I managed to do that. So the thermostat is free of the connectors now. Next step, remove the thermostat, and you need to loosen the nut holding the thermostat to the boiler.
This is a bit too small. I guess we need a spanner. Alright. See that?
I found the best way to do it was to use the spanner and access the nut from the bottom. So there you have it, and
So
remove the nut the rest of the way using your fingers. The thermal paste on the thermostat is pretty messy. You do not want your group head to be contaminated by it. So there's the thermostat we have just removed.
Okay.
You may keep it aside in case you want to put it back again one day. And now we are going to replace the thermostat with this thermal sensor. We will start by applying the thermal paste provided in the kit, and just a little on the thread of the new sensor, and not to forget the washer that is part of the thermal sensor. Apply some thermal paste over it as well.
Both sides.
A thin layer of thermal paste is good enough.
That should be good enough.
Next step, screw in the new sensor in place of the thermostat. This will be quite straightforward. The difficulty you will face will be the cables, because they are very stiff and it gets in the way while you're trying to screw in the sensor. So my advice is to remove the cable tie from the bunch and let the cable hang free. So now the last part is to tighten in the sensor. The critical thing to note here is not to over tighten. So after finger tightening, add another about quarter turn with your plier, and that's it. You do not want the new sensor to break inside the thread of the boiler, because that will spell trouble. Finally, we should check the sensor lines. Between the red and the white, it should be around 110 ohms, and between the red lines, of course, should be common. With this, we are assured the sensor is not broken and is properly installed.